welcome to Introduction to Trigonometry. Just before we start, just want to remind you that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So just to start, what is trigonometry? Well, it comes, like many things in maths, from Greek. It comes from the Greek trigonon, meaning triangle, and metron, meaning measure. Trigonometry is simply the measurement of elements of a triangle, so that's sides and angles. And the trigonometry we're going to look at today is all to do with right angle triangles. And so in each case we'll see a right angle and we'll have an angle. Now this is the Greek letter theta. It's the symbol we use to represent an angle in maths. In these questions we're either going to be told an angle in the triangle, or we're going to be looking to find the angle in the triangle. But it's very important where that angle is, because we need to label the three sides of this triangle. And those three sides are going to be labelled as hypotenuse, opposite and adjacent. Now the hypotenuse you may well already be familiar with as the longest side in a right angle triangle, but the key here is that the hypotenuse is always directly opposite the right angle, and so the hypotenuse will always be opposite that right angle, making it the longest side in the triangle. So we will always label that one as the hypotenuse. The other two sides, the opposite and the adjacent, are all based around the angle we've been given or that we want to find, because the other two sides are going to be labelled based on that. So we have the angle here which we want to know, theta. The opposite side, well, that one comes quite simply from the side which is opposite that angle. And so opposite the angle we've been given in this case would mean at the bottom. The last one is adjacent. Now quite clearly it must be this side here, because it's the only side that's left. But the word adjacent actually just means next to. So it's the side which is next to the angle. So our first task in this video is to actually just practice that labelling of the diagram, because if we don't label the diagrams correctly, we're not going to end up doing the working out correctly. So it's very important that we do recognise which side is which in each case. And I would always begin by labelling the hypotenuse, and that's because it's the easiest one to find. It's always opposite the right angle. And so in this first question, opposite the right angle would be the 6 centimetres. So I'm just going to label that H for hypotenuse. Then it comes to the angle we've been given. In this case we've been given 30 degrees here. And so the side which is opposite that angle is going to be the side O, which we'll call opposite, or O. And the last one, well, that is the other one that's left over, the adjacent, because it is next to the angle that we started with. In the next question, again, always start with the hypotenuse. We want the side which is opposite the right angle. Well, there's the right angle, there's the side opposite it, so there's the hypotenuse. This is the angle that in this case we want to find, because we've labelled it theta, and so the side opposite to that angle is the one we're going to call O, and the one that's left over will have to be A. In the third one, again, start with the right angle. The side which is opposite the right angle. It's in a very different position this time. It's actually at the bottom of our triangle, but that's fine. Right angle triangles can be in any orientation that they want. So there's the right angle, there's the side opposite it, so that will be the hypotenuse. Then the angle we've been given is here, so the side opposite that would be over here. There's our opposite, leaving adjacent at the top. If we keep going, we've got a right angle triangle this time that's been flipped around so that the right angle is right at the top. Changes nothing about our method. The side opposite that right angle is our hypotenuse. The angle we've been given, 40 degrees, the side which is opposite that one is the opposite, and leaves us with adjacent here. Then in the 9 centimetre, 8 centimetre triangle, well, there's our right angle. Side opposite it is the 9, so there's our hypotenuse. There is the angle we've been given. The side opposite it is the 8, leaving us with the last one, the adjacent, next to the angle. And finally, our triangle this time is just flipped in the other direction, but our right angle is here, so the side opposite it must be the hypotenuse. The angle that we're trying to find, the side opposite it, gives the O, and so the last side, the 10 centimetres, must be our adjacent. So when it comes to right angle triangles, the sides and the angles will always be connected by ratios and functions, and these are called sine, which is often shortened to sin, cosine, which is often shortened to cos, and tangent, shortened to tan. Now you may have noticed those buttons on your calculator before and wondered what they were for. Well, this is the reason. And each of these is related to a relationship between the angle and the sides in the triangle. So the first one is that sine theta equals the opposite side divided by the hypotenuse. With cosine or cos theta equals adjacent over hypotenuse. And for tangent or tan theta equals opposite over adjacent. Now, if you can remember those three rules, you're going to be in a very good position for working out anything to do with trigonometry. But you may also just want some other versions. Now, in science, you use a lot of formula triangles. Well, we can do the same with these relationships here. We can create a formula triangle for them. So sine theta equals opposite over hypotenuse. That would create a formula triangle of SOH. Just remembering that at the bottom, this always means multiply. And it is very important that where we think about S, meaning sine, that we are thinking that that is sine theta, that we are relating that to the angle that we've been given or the angle we want to find. For cos theta, same thing. We can make a formula triangle. It's going to be a CAH triangle. Again, there's a multiplication going on in between. And the C for cos must relate to the angle we've been given. And finally for tan, well, that is going to be a TOA triangle. Again, a multiplication at the bottom, and that is tan theta. Now, all of these are quite long-winded, no matter what. There's no real way that we can get around that. But there is one more way that you might remember these relationships, and that's through the use of the phrase of SOHCAHTOA. It's just a way of relating together all of the pieces we need. So we have SO, sine opposite hypotenuse, CA, cosine adjacent hypotenuse, TOA, tangent opposite adjacent. And it's just a way of reminding us of which bits work. So we're going to try to put together all three of these today in the examples that we go through. Okay, so we're going to start with the three triangles in which we, when we labelled them, they already had the angles included. Because in each of these cases, what we're actually going to be trying to do is we're going to be trying to find a missing side. So in our first example, we know we've labelled them with hypotenuse, opposite and adjacent. And all we need to do is, first of all, just have a look and see which pieces of information are going to be useful. Well, the hypotenuse is going to be useful here because we know that it is 6 centimetres. The opposite is going to be useful because that is the side we actually want to calculate. If we have a look at the adjacent, there is no information and therefore it's not going to impact our answer. And so, all we want to do each time is start off with that little phrase of SOHCAHTOA. And we do this so that we can just have a quick look. We've got H and we've got O. So what we need is the combination that includes O and H, and in that case it's going to be so. So that is sine. Therefore what we're going to do is we're going to draw our little formula triangle for sine, which is SOH. And in this question, what we are looking for the opposite, and therefore we're going to cover over opposite on our formula triangle, and that tells me that the opposite is going to be sine, and that is sine of 30, always relating to the angle, sine of 30 times the hypotenuse, and the hypotenuse is 6. All we're going to do is grab our calculator and we'll type that in. Now if we press sine, we notice that it actually pops up straight away with a bracket, and that's just to make sure that the angle is what the function of sine actually operates on. But we need to also make sure that we close that bracket so that the function sine is only working on 30, nothing else. And then times 6, and we get an answer, a lovely answer this time. It is just an answer of 3. And so the other side in that triangle, the one that we called X, will be 3 centimetres long. We'll do the same for the next triangle. So in this case, the piece of information that I already know is the adjacent. The piece that I want to know is the hypotenuse. The opposite has nothing included on it and therefore isn't going to be in our working. So again, let's just write our phrase, SOHCAHTOA. And we want this time to just identify which one has has A and H in it. And so in this case, that is Ca for cos. So we'll draw our little formula triangle for cosine. So that's C-A-H. And in this case, the value we are looking for is the hypotenuse. So we'll cover over hypotenuse on our formula triangle. And so that is telling me that the hypotenuse will be the adjacent, which in this case is 4, over cos of the angle, 45. And so all we're going to do is we're going to pop that into our calculator. This time we want to use the fraction, and it's going to be 4 over cos 45. And again, make sure to close that bracket and press equals. And we get an answer of 4 root 2. Now that is the exact answer, it is the correct version, but most likely we'll want this as a decimal. So press the S to D button to turn it from a surd to a decimal. And that is 5.66 to 2 decimal places. So 5.66 centimetres to 2 decimal places. In our final example, going to do exactly the same again. We know that we want to find the adjacent. We know the value of the opposite. The hypotenuse has no information related to it, and therefore we aren't going to use hypotenuse. And so all we're going to do is write down SOHCAHTOA again. And from that we just need to identify which one includes O and A. Well, that is TOA for tan. So we're going to draw our little formula triangle for tan, which is TOA. And in this question, the value we are looking for is the adjacent. So I'm going to cover that over, and that is telling me that the adjacent is going to be the opposite, which is 3, divided by tan of the angle, so tan 40. And again, grab the calculator and type that in. We want a fraction, 3 over tan of 40, close the bracket and press equals, and this time we get an answer straight out of 3.5 8 centimetres to 2 decimal places. Okay, so in the other three questions, it is the angle that we're trying to find. They are marked as theta in the diagram, and so it's the angle we're trying to find. Now, as this is the opposite version, there is a little bit more to these questions. We need one little trick in order to get the answer out for the angle, but we still need to set it up in exactly the same way. So we've labelled all of the sides: hypotenuse, opposite and adjacent. And we're going to do the same thing again. We're just going to check which value do we know. Well, I know the opposite, and in this case I know the adjacent. The hypotenuse has no information on it, and therefore is not going to be important in this question. I'm still going to need to use SOHCAHTOA. And in the SOHCAHTOA, I'm just going to decide which one includes O and A. Well, the piece that has O and A in it is tan. So again, same idea. I need to draw my little formula triangle of tan, which is TOA. And we're trying to find this case. We're trying to find the angle. Now, the angle is always associated with either sine, cos, or tan. So in this case, it's actually tan that we are going to cover over. And so what that says is that tan theta equals the opposite divided by the adjacent. So it equals 8 over 3. Now, the difficulty here is that tan is actually a function. It's something which happens to the angle. So we need to undo that function. And so we need to know the inverse of that operation. And the inverse of the operation is actually known as tan inverse. It is tan with a little -1. Now, personally, I call that one shift tan. And the reason I call it shift tan is that if I want to get it on my calculator, I press shift and then tan. And you'll notice it comes up as tan to the -1. Now, the key here is that to get theta on its own, we actually have to do tan to the -1 of the fraction that we have formed. So 8 over 3. That will create the answer theta, what we were actually looking for. And so that's what we need to type into our calculator this time. We need to pop the fraction 8 over 3 into the calculator. So tan inverse or shift tan of 8 over 3, it equals 69.44. And that is the size of the angle. If we go to our second question, we do the same process. We want to see which two sides do we actually know values for. Well, we know the hypotenuse, we know the opposite, the adjacent has no important information. And so again, we just want to go to SOHCAHTOA. And in this case, we have O and H. So which section has O and H in it? It is this one, sine. And so we're going to use our little formula triangle for sine, SOH. And that tells me that sine theta equals the opposite, which is 8, over the hypotenuse, which is 9. If I want to get theta all on its own, this is where I need to do the same thing again. I need to be thinking about shift sine, or the inverse of sine. So sine to the -1 of the fraction that we have formed, 8 over 9, that will give us theta. And so if we type that into our calculator, shift sine, and then the fraction 8 over 9, it will give us the answer of 62.73. And that is the size of our angle. Finally, if we look at the last question, same idea again. Which two sides do we have information about? Well, I have the hypotenuse, I have the adjacent, the opposite is not giving me any information, and so we're just going to write out our phrase, SOHCAHTOA. Which of those includes A and H? Well, in this case, it is CA for cos. And so we'll draw our little formula triangle, CAH, and it is the cosine, yet again, that we're looking for. And so that is telling me that cos theta equals the adjacent, which is 10, over the hypotenuse, which is 12. And therefore, if I want to get the angle all on its own, I need to use my shift version. So cos to the -1 of 10 over 12 will give me theta. And if I just grab my calculator, well, shift cos of 10 over 12 equals, in this case, 33.56 degrees. And there's the size of our angle. And so we end with our exam question. And this came from the Edexcel paper in June 2018. It was on Foundation and Higher Paper 3. So it is one of those crossover questions. It's a grade 4 to 5 topic. And it's paper 3, so it is a calculator question, so we can use our calculator when we want to. So we're told that ABC is a right angled triangle. And we're asked to work out the size of angle ABC. Give your answer correct to 1 decimal place. So here we have a right angle triangle. We've even marked in the angle that we're trying to find, but let's call that one theta, as it's the angle we're trying to find. And now comes all of the elements that we've looked at so far. So the first thing we need to do is we need to label the diagram. So starting off with the hypotenuse, our right angle is at the bottom, so the side which is opposite it would be the hypotenuse. The angle that we want to find, the side which would be opposite that, is the opposite, and the one that's left over, the one that's next to the angle, is our adjacent. We need to decide which of the three ratios are we going to use, sine, cos or tan. So again, we want to look at which of the sides do we know. Well, we know the hypotenuse and we know the adjacent. So again, let's just think about SOHCAHTOA. Well, if we look at that, which one includes A and H? Well, that is CA for cos. And so we're going to draw our little formula triangle for cos, CAH. And this time it is an angle that we're looking for. So again, we'll just cover over our cos in this case. But that is telling me that cos of the angle I'm looking for equals the adjacent over the hypotenuse. The adjacent is 7 centimeters, the hypotenuse is 11. But because it's an angle, again, we need to get theta all on its own. And so we need to do our inverse, our shift cos of this fraction. So it's cos inverse of 7 over 11. We grab our calculator in order to just check the answer to that. We press shift, cos, we have our fraction, it's going to be 7 over 11, and we press equals, and we get an answer of 50, and it asks, in this case, 1 decimal place. So let's just check what that answer would be. 1 decimal place, 50.5 degrees. Now that was part 1 of the question, using trigonometry. The second part is just having to think a little bit about what we're actually dealing with. It tells us that the length of the side AB is reduced by 1 centimetre. So the first thing is that AB is this side here, the one that goes from A to B. So if it's reduced by 1 centimetre, that has now become a side of 10. BC is still 7 and ACB is still 90. Will the value of cos ABC increase or decrease? you must give a reason for your answer. Well, now this comes back to our formula triangle. Cos theta equals adjacent over hypotenuse. So in the original question, cos theta was 7 over 11. In our new version, this length here, the hypotenuse, has reduced. And so in the new version, cos theta equals 7 over 10. Now all it wants to know is the value of cos ABC. Will it increase or decrease? So will the value be bigger or smaller now? Well, which of these is a bigger value? Is it 7 over 11 or 7 over 10? Well, if you divide something by 11, it's going to be a smaller piece than if you divide it by 10. And you can check that quite quickly because we already know we can use our calculator. So if I do 7 divided by 11, I get, as a decimal, 0.63 recurring. So I can call that 0.63 recurring. If I do 7 divided by 10, well, straight away, I know that that is 0.7. And so, which one is the bigger value? Well, it's our new version. And so it asked, has it increased or decreased? Well, to get from the first one to the second, it has increased.